guys section 9, okay, exponential models, okay, this is on page 107, okay. So for this section 9, let's assign the pages we're going to cover, okay. So I want you guys to do the entire page of 107, the entire page of 108, entire page of 109, entire page of 111, on page 116, entire page. This is Excel part, okay. Usually I let you guys to self-practice Excel, okay. But on page 116, okay, this is an example, okay, for us to compare the linear model and exponential model. So this page 116, we do it together in class, okay. So this is entire page 116 we do in class, okay. Page 117, this is about the practice in the Excel. This is a self-practice, okay. Page 118, self-practice. Page 119, the top part, it's still the Excel part, okay, so you self-practice this, okay. And then on the bottom part of page 119, we do interest, okay. So I would say the entire page of 119. Page 120, entire page. Page 121, do question 4. In the connect part, do question 1, A, B. Okay, yeah, do question 1, A and B, okay. Page 122, let's do the discover part. Also, connect part, question 1, A, B, and C. Okay. Page 124. Page 124, this is a rule of 70 for doubling time. This was a mandatory part in our older version of the textbook, but we kind of chopped it, okay? This is an Explore. I would say that let's leave this alone and let me double check whether you have homework assignment from that part or not. If not, we don't have to worry about this page, okay? So that's it, okay? That's it. We don't have to worry about 124 at this point, okay? So section 9, as you can see, is divided into 2 parts. The first part, it is about exponential model, okay? The second part, it is about what? Interest, okay? Interest, okay? So the interest part is the second part. It's on page 119, okay? So we'll talk about this interest in the later time today in class, okay? At first, we will do the exponential models on page 107, okay? Yeah, so let's start from page 107. We look at the exponential model, okay? And for exponential model, there are 2 types. One type is exponential growth. Okay, this is a type 1, okay, the growth model, okay. And type 2 is about what? Decay, okay. On page 111, you will see exponential decay model. So this is type 2. Yeah, So just for explanation model, you have to master both types, okay? So let's start from the first type, the growth model, okay? Growth model, okay? I'm going to ask a volunteer to read this question for us, and then we will fill out this table together, okay? Whose turn? Cassie?
Consider the following situation. Oliver opens a retirement account by depositing $1,800 in the initial year. He intends to increase his deposits by $100 in each subsequent year. How much does Oliver expect to deposit in year 1 and year 2?
Okay. Hold on. All right, how about question 2?
Use the table below to chart the expected total of Oliver's deposits by year. Calculate the absolute and relative change from the previous year to explore the pattern.
Okay, very good. Okay, so Olivia opened this account by depositing $1,800 in the initial year. Okay, so how much does Oliver expect to deposit in year 1 and year 2? In year 1, how much?
$100.
Yeah, yeah. Okay, well, let's fill the table first, okay? Then answer that question, okay? So, initial year, okay, year 0, he had this amount deposit for that year. It's what? $1,800. That's the initial value, okay? He intends to increase his deposit by $100 in each of these subsequent year. Okay, so in year 1, okay, he should deposit how much? $1,900. And then in year 2, he should deposit how much? $2,000. So how to answer the first question? If $1,800 is for year 0, in year 1, he should deposit what? $1,900, right? In year 2, he should deposit what? $2,000. Okay, and then can you also fill out this entire column? In year 3, he should deposit what? $2,100, and then in year 4, $2,200. So we have our values for each of these years. Okay, we're also going to compare the absolute change and relative change from the previous years. Okay, let's do the absolute change. Before $1,800, do we have any previous deposit between this year? No. Okay. All right, so we start from here. Okay. Year 1, $1,900, year 0, $1,800. What's absolute change? What's this absolute change? From $1,800 to $1,900, we have what? What's the new value? $1,900, right? What is old value? $1,800. So what's the absolute change? $100, right? $100. And from this previous year to this new year, okay, old year, new year. Absolute change. New minus old. New minus old. Does everybody agree with this column? Right? Now let's compute relative change. Okay? Do you remember how to compute relative change? Relative change equals new value minus old value, or absolute change divided by what? Old value. New minus old, 100. We'll just use absolute change directly. Divide by the old value. What is old value among these two? 1,800, right? So 100 divided by 1,800. Can you give us a decimal number?
0.055.
0.055. Can we round? Do we round to 0.055? It's 0.055555, right?
Yeah.
So I would say 0.056, right? because we have to round up, right? 5 is we round up. Now let's look at this part. Percentage increase from the previous year, because this value, okay, relative change give us percentage change. Okay, if we have a positive result here, that means we have a percentage increase, right? Because this value is positive. Okay, so what is a percent increase from the previous year? Relative change give us a decimal number, so the percentage increase should be what? 5.6%. Means what? Oliver's deposit in year 1, okay, compared with year 0 is what? 5.6% more, right? That makes sense, guys? Can you try to fill out the rest of the, table? Relative change from the previous year. Now we're comparing these two values. Absolute change is still 100. What is old value this time? 1900. Please finish this entire table. Right? Okay, now let's try to answer these following questions, okay? Question 3. How is the total amount of deposits changing from year to year? What's the change? Every year is what? $100 more than the previous year, right? So I would say add $100. Which value stays the same? Absolute change or the relative change? Which column this result, the value, those result remain the same? Absolute change. Well, for this model, absolute change remains the same, stays the same. Without continuing the table, how can you mathematically find the total amounts of Oliver's retirement contributions in the 6th year? 4th year, this much. 5th year should be what? 2,300. How about 6th year? 2,400, right? 2,400. So we know the answer is $2,400. But is there any way we could have, express it or describe it, mathematically find the total amount? Begin with 1,800, then after each year is 100 more than previous, right? So 6th year, that's 60 years after this initial year, right? So we should have a 100 times by 6, $600 more than the 1,800, right? So we add the $600 on the 1,800, that gives us the $2,400. Right? That's how we compute it mathematically, okay? So what I would say is multiply 6 by $100 and add to what? 1,800, okay? Yeah, and add to the 1,800. That will give us 2,400. That makes sense, guys? Every year, 100 more, after 6 years, his deposit should be 600 more than the 1,800. So add them up, give us $2,400, right? Okay, question 6. Use initial value for year 0 and absolute change from year to year and the pattern by which the value of deposits are increasing to find a mathematical model that will give us amount of the deposits in any given year. How can we build a model? So far, we only learned one type of the model. What is that? Linear model. Okay, y equals mx plus b, right, so far. Now for this linear model, y equals mx plus b, we know m gives us the slope, like a steady change year by year, right? So does this model satisfy we have a steady change year by year? Every year $100 more, every year $100 more, right? So we have an increase of $100 per year, right? We have a positive $100 per year. So this 100 gives us what? Slope. Remember the milk problem? Every 1 gallon of the milk you buy, you have to pay $3.30 for a 2% milk, right? Remember that? So this is after 1 year, we have 100% more. After that year, 100%. So this 100 is the steadily increasing number. So I would say this $100 is our slope m, okay, and m times x plus what? The initial amount, okay, or the starting point, right? What is the starting value? What is the initial deposit for Oliver? 1,800. So 1,800 is our b value. So y equals 100 times x plus 1,800. This is what? Our math model. So let's double check whether this model is indeed our model, okay? Remember from the previous question, we are asking, okay, how much retirement contribution in the 6th year can Oliver contribute, right? So how about using the model to compute it? After 6 years, when x equals what? 6, right? 100 times 6 plus 1,800, does it give us 2,400? Yes, okay. Now we're using this model. Let me ask you another question. What is the total amount of Oliver's retirement contribution in the 10th year? 10th year. What do? Replace x by 10, right? That gives us 1,000 here plus 1,800. The answer should be 2,800. Right, guys? Yeah. Okay. Okay, so this is our model. What kind of this model is? Linear model. Yes, linear. Okay. Okay, I'm going to ask a volunteer to read this paragraph for us. Evan?
When the absolute change is the same from time period to time period, the mathematical model is linear. The model can be written using the equation y equals mx plus b. The slope or rate of change m is the absolute change and the y-intercept b is the initial value.
Very good, thanks. Okay. Absolute change is the same from time period to time period. Then, okay, absolute change is the same. Okay, then the math model is going to be what? Linear. Okay, so why emphasize on this? Because later we're going to learn what? Exponential model. Okay, so before that, okay, we know absolute change remains the same, give us a linear model, and that absolute change will be what? The slope. Okay, take example, guys, this model. In this model, absolute change is 100, right? So what is the slope of the linear model? 100, okay? So absolute change gives us the slope of the linear model, okay? It says here, slope or rate of change is absolute change, okay? And the y-intercept, which is also the b-value, comes from what? The initial value given in the problem. So 1800 is what? The initial value, okay? You guys clear about this paragraph, the idea? Okay. Can we move on? Yep. Next page. Let's try another strategy, okay? So let's look at this question, okay? This one, okay? I'm still going to ask a volunteer to read this question for us, okay? Christine?
What if Oliver increases his deposits by a percentage each year rather than a specific dollar amount? From our previous scenario, Oliver realizes that $100 is roughly 6% of his current contribution. He decides to increase his deposit by 6% in the coming year, then increase that by 6% in the following year, and so on. If Oliver increases his total retirement deposits by 6% in the first year, how much money will he deposit by the end of the first year?
Also question 9, please.
Use the table below to chart the amount expected each year when Oliver increases his deposits by 6% each year. Calculate the absolute and relative change from the previous year to explore the pattern. Round each deposit amount to the nearest cent.
Okay, very good, thanks, okay. Okay, so now Oliver changed, okay? He's not deposit what? He doesn't deposit by what? Increase by a specific dollar amount. He's going to use what? Percentage increase this time, okay? So let's answer question 8. If Oliver increased his total retirement deposit by 6% in the first year, okay, we know that in year 0, that's initial value is 1800, okay? So increase by 6% in the first year, how much money will he deposit by the end of the first year? Compute the deposit in the first year or at the end of the first year. How can we do that, guys? 6% more, right? Yeah, 6% more than previous year. Then actually, he is depositing what? $1,800 times by what? Times by 100% plus 6%, 106%, right? So let me say this is 106%. Because he's depositing 6% more, which is 106% of the 1800, right? And then we can do it like this, 1800 times by what? 1.06, and then how about you give me a number? And round your answer to what? To the nearest cents, right? But I don't think we have a cents, because we should still get an integer here at this point. 1908. Okay. Yeah, so the nearest cents, this is for the next question, okay? So we're gonna input 1908 here, okay? And then in the second year, the deposit will be 106% of 1908, right? So how to get a number here? Use 1908 times by what? 1.06. Let's see what value you get. Do you have a decimal number? If you have decimal number, make sure you run it to the cents, okay? Make sure we run it to the cents. What do you get? I have a 2022.48. Do you get the same answer? Well, same thing. In the third year, it is 6% more than, the second year. So we use this number times by 1.06. Right? and use this number times by 1.06, give us. Right, everyone?